Okay, Jennifer McCullough is a senior passive acoustic associate with JIMAR in the Cetaceans Research Program in the Pacific Islands Fisheries Science Center. She has a master's degree in biological sciences from Cal State San Marcos and has worked at both the Pacific Island and Southwest Fisheries Science Centers, developing innovative ways to collect acoustic recordings from our oceans.
I'd just like to take a moment and introduce my co-authors, Aaron Olson, Ann Allen, Johanna Wren, and Marie Hill. So to start, where is the Mariana Archipelago? We are headed into the Western Pacific, where Guam and Saipan, so head west. The Pacific Island Fisheries Science Center conducts abundance surveys to understand distribution and abundance of cetaceans in different bodies of water in the Pacific. In the summer of 2018, we did the Mariana Archipelago Cetacean Survey, also known as MAX. Traditional surveys involve a visual team and an acoustic team, and in those surveys, the acoustics teams use sonobuoys and a towed array that you can see trailing behind the ship to assess cetaceans. During this survey, we implemented a new form of assessing cetaceans, which is known as a Jasper. What is a Jasper? A Jasper is a drifting acoustic spar buoy recorder that was designed this version was designed at the Pacific Island Fisheries Science Center. It contains a satellite iridium tracker in the buoy, a surface float trailing for visibility and so that we can grapple it to bring it back onto the ship. It has 140 meters of line, and then it has a subsurface float for buoyancy with an additional 15 meters of line and then an anchor. So that subsurface float and the anchor goal is to keep that portion taut so that my hydrophones stay in the same line, even if the ocean is making me move while I'm drifting along and the top portion has some form of a tilt. So there's two hydrophones spaced 10 meters apart with a sound trap, which is an acoustic recorder that collects all the data, and then I need to retrieve the instrument in order to assess the data. So for future slides, this is what a Jasper will look like, line and two hydrophones. So why use Jaspers? Jaspers are a unique platform because they are drifting and we're no longer tethered to the ship. They are out for probably 2 to 3 weeks and we have to come back and retrieve them. So there's no continuous ship noise associated with. The hydrophones are at depth of 150 meters, so there's less surface noise. And then we're able to assess deep diving cetaceans that spend little time at the surface and more time at depth, so the instrument gets to hang out in the water as they pass through. So the research goals for this project were to survey using a more robust version of a Jasper because our oceans need a little bit stronger material. So I call this the PIFSC Jasper. Increase our cetacean encounter rates in the Mariana Archipelago, explore environmental data compared to whatever detections I find, and then model environmental data with those detections. So what did our Jaspers do? We have 8 tracks that all traveled from east to west. All 8 Jaspers were put into the water, it kissed them goodbye, and we got all 8 back. Amazing, because whatever you put in the ocean doesn't always come back. It traveled for 19 days, cumulatively, over 1,500 kilometers of track, which is fantastic. Nice coverage. So we did this initial assessment of just looking for deep diving cetaceans using echolocation clicks. So because there's no visual component to these recorders, and deep diving cetaceans like beaked whales and dwarf and pygmy sperm whales, I can look at the acoustic signatures and know that what species is what each individual species. So what species did we find on this 19 days of recordings? So we found Blainesville beaked whales, Cuvier's beaked whales, Longman's beaked whales, and then what we refer to as the cross seamount beaked whale, and the cross seamount beaked whale has no picture next to it because we don't know what it is. We are constantly trying to, with many other efforts, including eDNA, try and figure out what this animal is because we have lots of acoustic recordings, but they're only vocal at night, so it makes my job very difficult. And then we lump together dwarf and pygmy sperm whales because on the Jaspers, and I refer to them as Kogia for the genus, because we can't tell them acoustically apart on a Jasper. So here is the 8 track lines with all the detections mapped onto it. So what these counts represent are the dive cycle of a beaked whale. And so it's groups of recordings. So I may be tracking the same groups of animals, that is possible, but I've at least lumped it into a dive. And these animals are only making this type of echolocation click at depth while they're foraging. So during that same survey, so here's our 163 detections. And we were out during that survey for 23 days doing the acoustics and visuals. So compared to the towed array that was behind the ship, we were only able to assess 9 groups of these deep diving cetaceans, which compared to this in the same time to our visual team, we only had 2. So what we've been able to see is that using these drifting recorders allows the instruments to spend more time in the spaces and at depth where those animals are. Because if I'm driving with the towed array over a very limited space, my chance in a couple hour time period is limited that I will pick them up. So we're able to increase that way. So now I've taken these detections, and for the next couple of slides, we're just talking about exploring data and wanting to look at environmental variables that maybe impacted where I heard those animals. So we take all these factors, we have some information from the Jaspers, some ocean mapping, and then some satellite data that I was able to correlate. And these all have points that match along each of those drifting track lines. So just a box plot of each of those variables compared to 0, meaning nobody on that track line data point, or one of these deep diving cetaceans is a 1 on that point. And the thing when we're just taking an assessment that stands out is that latitude seems to be something that is a feature we want to look more into. So if we go back to the graph with all of the tracks on it, and you look at where those detections are, we arbitrarily drew a line at 15.5 degrees latitude and see that there are significantly more detections in what I'm referring to as the north versus the south. So in continuing our exploration of the data, we took CTD data, conductivity temperature data, and there were 15 stations during the same survey. So if I divide in that same space, the 15.5 degrees, I have 6 casts in the north and 7 through 15 are in the south. So just looking and grouping those sets of casts, you can see that something is splitting between the north and the south in the 200 to 600 meter range. And that in the north, at the deeper depths, the water is warmer. So, interesting. All right, so if we look at the salinity, the same type of division happens between the north and the south in the 250 meters down to 1,000 meters. So now we've noticed that there's something different between the bodies of water in the north versus the south. So we wanted to take latitude and longitude out of our modeling, and we're just starting into modeling, and wanted to, now we've removed latitude and we're only looking at these features. The temperature that is the TDR is at 150 meters. It's at the bottom of the Jasper. And then the sea surface temperature is from satellite data, along with the other variables. So we looked at using a generalized additive model, and instead of putting all the variables in and discovering they were all significant, we did more of a stepwise attempt to tease out some of this information. And remember, just in the northern half. We've decided to not look at the southern. So the first thing that became significant was bathymetry, and then the second that we were able to add into was sea surface temperature. So let's take a more closer look at bathymetry. So in the bathymetry portion of the model, you can see that we have detections from about 2,000 meters and a little bit higher. We're getting positive detections. So, and that's not surprising to us because beaked whales in these deep diving cetaceans are found a lot along seamounts and the features where they're dropping off. And then there's a lull in the 3,500 to 4,000 meters, and then it peaks back up again. And then you can see the bathymetry mapped over just the locations in the north. And then the other significant piece was the sea surface temperature, and it's just a little bit that you can see that in cooler waters we're getting more detections. And really what we want to look at is more of that CTD information and looking at the water column with the 200 to 600 meters, because there seems to be something more going on there than just what's on the sea surface. So in summary, and for future work, the Jaspers improved our methods in detecting deep diving cetaceans. We expanded our knowledge of beaked whales and Kogia distribution. Bathymetry and sea surface temperature are clearly playing a role, but we want to further more information about that and want to incorporate the CTD data, and that's my next week's project. I'd like to acknowledge the design and construction staff at the Pacific Island Fisheries Science Center that helped redesign and build these more robust versions of Jaspers. Many of them are sitting here today, and I thank you greatly because I was able to retrieve them all. And the crew from the SETI and our MAX field team for helping us spot them and bring them back, and NOAA and the Navy for funding. Any questions?
Questions for Jen?
You get to go to lunch faster.
Go ahead, Frank.
I defer to somebody who's got a more informed question.
Scott, go ahead.
Well, my question was, how do you have plans to convert these into density data?
Oh, yes. So there's many steps to that point, but right now I have to make sure. So I told you that the subsurface float and the anchor are holding my hydrophones hopefully in place. And there's an accelerometer in the sound trap. So we're trying to assess our level of tilt within the instrument and where our comfort level is so that I can assume that my instrument is straight up and down. So once I can do that, then yes, these deep diving cetaceans produce sounds that then bounce off the surface and allowed me to have a virtual hydrophone at the surface and at depth so that I can give a depth and range of the animals and then get to density. But I have a couple things to verify first. Frank, did you want to ask your question?
Your cross seamount animal.
Yes.
It's interesting, we're just hearing about it cross seamount. Is there any chance there's an attenuation of the signal if something's feeding on the bottom down there? And no chance.
No, so yes, so it got its name because it was the only beaked whale found on an instrument that was moored next to the cross seamount. And then due to the surveys that we've done in the Marianas, and I've done other drifts of Jaspers throughout the Hawaiian Islands, I found them in lots of other locations. So we have lots of data to talk about this animal when we find out who it is.
Sasquatch of the sea.
Okay. We have seen a body once in the twilight swimming away, but I can't tell you what it is.
Thanks, Jennifer.